the paper trickier than like this?
I thought this time round the E is a bit tougher than the A. I thought, but it's only because there's more explanation question than A. Okay, A is if you know all the important things per chapter, there's no traps. Yes.
Like ace your explanation questions.
Some very difficult to explain.
Yeah, it is. That's why I'm asking this one.
Is there a way? I can compound more for y'all to see a trend. Somehow there's a trend to how they always ask the question.
Can you explain the trend?
Okay, wait. Let me overview this. Chapter 3.1 to 3.3 is all about the 9 rules. So the rules or the laws of indices. Okay, we will start from AM. Okay, you add up. Second one, if you divide, then it's minus. I still have some of you divide, don't know what to do. Okay, if I subject both to the same power, both of them should get the same power. Same thing for fractions. Or maybe I use n for consistency. Okay, both will get the same power. If you have power 0, it is 1. Okay, if you have negative power, you can bring it down. If you have a fractional power, it is always a root. Okay, if you subject it to another fraction, you can apply the root to power m. Okay, the very last one is if you have two numbers with different powers but the base is the same, then you can conclude that x must equal to y. So this is the whole of 3.1 to 3.4, sorry. Again, this one I will put up. That one I did on board. A math I did on the board, right? Did I miss out one? 1, 2, 3, 4, 5, 6. Yeah, why? If it's like this, then it's m times n. Okay, I don't know why. How come got 10, meh? I always remember got 9. Okay, then let's put 10 then. Did I repeat something by mistake? Okay, shh. Next one, 3.5 is compound interest. Or was it standard form first?
This one already goes straight from 8 to 10.
Wait, no, 1 and 9 is the same thing, no?
Where?
First the multiply the bracket, the multiply.
No, this one different. Separated by a bracket, you multiply the power. Different. This one, you add the power. Sorry? Block will apply this principle in the same way. Okay, compound interest. Yes.
How about like if it's not a bracket and it's square root and is it divide?
Square root n? Like that?
No, like n is outside and m is inside.
Which is this one, right? This one?
I don't think 3 exists. 3 does exist, man.
Yeah, 3 exists.
Okay, you think about it. Okay, compound interest. This formula is given to you on the first page. Okay, the only thing you need to think about is whether it's compounded annually, half yearly, quarterly, okay, or monthly. Okay, so when it's annually, you will just apply the rate to be R. Half yearly, you half it. Quarterly, you divide by 4. Monthly, you divide by 12. Okay, and then the time period, it will be n years, n times 2, n times 4, n times 12. So this one tells you the total number of months, number of quarters, number of half years, and years. So this is the only thing that can differ for compound interest. Other than that, the rest is just going back to this formula. So just a side note to remind you, A is P plus I. Okay, it's the amount at the end of a time period.
Technically, the interest amount is the bracket N, or is it?
Yes. Okay, next one. Shh. Okay, listen. Next one is simple interest. Simple interest formula is not given to you, so you have to memorize it. So it's IPRT over 100. So every time this is a yearly rate, and then this is a number of years. Okay, if it varies like monthly rate and so on, it will follow the table up there. It's the same thing. So all this, when you divide by 2, here it will become multiplied. So just take note of the difference. Okay, then next one is 3.6 standard form. So standard form, you just take note, we always express our answer A times 10 to the power of n. This A has a restriction, it must be greater or equals to 1 but strictly less than 10. So it's usually single digit. You wouldn't see a 11 point something. Okay, and if it's exact, then you leave it. No need to round off. Okay? Yes. Say? Said noise?
No, she saw in the book and there's 10 laws.
10, huh? Okay, okay, then it's fine. Okay, next one. Yes.
I meant like, first like, okay, alright, I mean like, I can do it by hand.
Then isn't it this one? Same thing. It's just like AM, then you power 1n. This one equivalent. Same thing. It's just I put the m first, then I apply the root. Or you want to apply the root first, then you put the m in. Also can. So they are equivalent. Okay, next one is chapter 4, which is coordinate geometry. Okay, 4.1, gradient. y2 minus y1, x2 minus x1. So it's rise over run. Okay, take note, when it's downward sloping, your rise is negative. When it's upward sloping, your rise is positive. So when you are using rise over run, you just need to take note of that. Okay, next one is gradient can be undefined if it's x equals to a. So when it's a vertical line. So vertical line means your x coordinate is the same. Okay, but when you have m equals to 0, you will have y equals to whatever your y-intercept is. Okay, let's use C then. Okay, so that's your equation. This is a horizontal line. So when you have a horizontal line, your y coordinates are the same. Okay, then of course, you will have other things like the length formula. Length or distance, you will use Pythagoras theorem. So x2 minus x1 square, y2 minus y1 square. Oh yes, yes, yes. Okay, so length is just this, nothing else. Then we have 4.3, which is the equation of a straight line. So you just have to use this formula to find equation of a straight line.
We are passing
Just passing. Okay, 4.4 is geometry problem. Yes. Yes, yes, yes. Okay, so geometry problem, right? Remember, they will give you any kind of shapes from triangles, parallelograms, trapezium, any kind. Then you have to go and find the math behind it. So this one, I can't really prepare you for it. Trapezium is half sum of parallel lines times height. This is for area.
What about the legs? The parameter.
Perimeter, just add all the 4 lines, but they won't ask like that. Okay, I just haven't go through 5.1, but